This is Module 2, the Anatomy and Physiology of Speech, Language, and Voice Production. In this module, we will have a brief overview of the anatomy required for speech, language, and voice production, and the structure's physiological function. In some of your other CSD courses, you will have more in-depth study of these structures and functions. It's impossible to talk about the anatomy and physiology of speech, language, voice production without mentioning the central nervous system. The central nervous system is comprised of the brain and the spinal cord. This important system receives sensory information and integrates those signals and organizes them in order to perform some type of action or motor movement. The first structure we'll talk about in the central nervous system is the brain. The brain is covered by 3 layers of membranous protection called meninges. The brain is also covered by the skull, which is not pictured here. It's a bony structure. The cerebrum is the topmost portion of the brain, and it is divided into 2 hemispheres, the left and the right. The corpus callosum is what connects those 2 hemispheres. The gyri are the ridges in the brain, and the sulci are the indentations that you see in the brain. The deeper indentations are called fissures. The brain is divided into 4 lobes: the frontal lobe, temporal lobe, parietal lobe, occipital lobe. It also has the cerebellum and brainstem. The frontal lobe, which is the blue area of the brain in front of you, is responsible for planning, reasoning, problem solving, motor functions such as speech motor, and is housed in the area called Broca's area. The temporal lobe is responsible for understanding language, hearing, memory, learning, and it has the sensory speech area called Wernicke's area. The parietal lobe is the lobe responsible for sensing body position in objects, time and space, reading and comprehension, associations between functions of other lobes. The occipital lobe is primarily responsible for vision and visual information, where the cerebellum is responsible for balance and muscular coordination. The brainstem regulates heartbeat, respiration, body temperature, and other essential functions. Let's review these 2 important areas for speech production. The temporal lobe, which is the lobe of the brain that is closest to the ear, is where the primary auditory cortex is. Because sound comes in the ear, the primary auditory cortex is where sound is processed. Remember, Wernicke's area is located here and is considered the primary language center, where language is processed. That language then transmits to the frontal lobe, where motor functioning takes place, in the area called Broca's area. We call this the speech motor area of the brain. I recommend that you read more about these functions in your textbook. The next structure of the central nervous system is called the spinal cord. The spinal cord is an extension of the brainstem, and it passes into a bony spinal column that is also a protection for the spinal cord. So remember, the bony protection of the brain is called the skull, and the bony protection of the spinal cord is called the spinal column. In addition to the spinal column, the spinal cord also is protected by meninges. Meninges are those membranous coverings that also protect the brain. The spinal column can be divided into 5 anatomical segments. They are named for where they are located in the body. Those segments are called the cervical, thoracic, lumbar, sacral, and coccygeal, because I've never told them. The next part of the nervous system that we'll discuss is the peripheral nervous system. What does peripheral mean? Peripheral means marginal or secondary, also near the surface of the body. So when we're talking about the peripheral nervous system, we're talking about two types of nerves, the spinal nerves and the cranial nerves. These nerves transmit messages. They receive sensory input, and they also take away motor output. Spinal nerves primarily transmit for body action and receive information sent to the brain. Cranial nerves transmit smell, vision, hearing, and taste, and also voluntary movements of the eyes, mouth, lips, tongue, and larynx. Cranial nerves innervate muscles. So what that means is messages from the brain go to the muscles through the nerves. They can send sensory messages or motor messages or both. There are actually 12 cranial nerves, and they're listed on page 26, table 2.1 in your textbook. I have listed only 7 here because there are only 7 that are responsible for speech production. Those 7 include number 5, the trigeminal nerve, and those nerves innervate muscles that are responsible for chewing and eardrum tension. The trigeminal nerve also has a sensory function and helps with feeling in the face and head. The next nerve is the facial nerve. Cranial nerve 7 helps with speech production. What it does is helps with muscles of facial expression, and the sensory component is how you can taste and feel in the tongue and pharynx. Sensory nerve number 8 is the acoustic nerve, and it has to do with hearing and balance. Cranial nerve 9 is the glossopharyngeal nerve, and it has to do with movement of the pharynx and with swallowing. The sensory component is with the tongue and pharynx. The vagus nerve, which is the number 10, it has a lot of functions. It innervates muscles that have to do with swallowing and laryngeal control, respiratory, cardiac, and gastrointestinal systems. The accessory nerve, which is 11, has to do with shoulder, arm, and throat movement. And then 12, the hypoglossal, has to do with tongue movement. It's important when you're learning these cranial nerves to know the number, the name, and the function. Another division of the nervous system is the autonomic nervous system. It can be further divided into the sympathetic system and the parasympathetic system. Although the autonomic nervous system isn't directly involved with speech or communication, it can be indirectly involved because it has to do with our emotional state. The sympathetic system, also known as that fight or flight part of our bodies, is responsible for protecting our bodies when we're in emergencies. And the parasympathetic system is said to bring our body back to rest or equilibrium. Let's move on and talk about speech systems. We can break speech down into 3 systems: the respiratory system, the phonatory system, and finally the articulatory system. The respiratory system has a biological function and a speech function. The biological function is breathing or sustaining life. The speech function is that it's the power source behind our speech. The respiratory system is broken up into the upper respiratory and the lower respiratory. The upper respiratory is the nose, mouth, throat, anything above the vocal folds, and the lower respiratory is the trachea, lungs. At the bottom of the thoracic cavity, we find a dome-shaped muscle called the diaphragm. The diaphragm, when it is contracted, it flattens out. And when it does this, it increases the size or volume of the chest cavity. So it flattens and then the chest cavity gets bigger. That's the first step in the process of breathing. There's an important law in physics called Boyle's Law that we must understand in order to understand what happens in respiration. According to Boyle's Law, as we increase the volume of the thoracic cavity, the pressure is lowering within the cavity. Because the pressure within the thoracic cavity is lower, the air pressure outside the body is now greater than the air pressure within the body. So as a result, air is now flowing from an area of high pressure to an area with low pressure. This process is known as inhalation. As the lungs fill up with air, the pressure is increasing inside the thoracic cavity, but the volume of the thoracic cavity decreases. When the air pressure within the lungs is greater than the air pressure outside the body, the air rushes out, and this is called exhalation. The breathing required to sustain life is very different than the breathing we need for speech. For speech, it's necessary for the flow of air at the larynx to build up in order to blow apart the vocal fold, cause vibration. The air also gets stopped at areas like the tongue or lips in order to create speech sounds. For normal breathing, we spend an equal amount of time inhaling and exhaling. However, for speech, we spend about 10% of the time inhaling while 90% is spent exhaling. All speech occurs during the exhalation process. And we adjust the air. The next system we'll talk about in speech production is the laryngeal system or the phonatory system. The laryngeal system is named that because of the structure called the larynx, or what you might have heard called the voice box. The larynx is made up of cartilage structures, the thyroid cartilage, the cricoid cartilage, and the arytenoid cartilage. The vocal folds are also part of the larynx. They are responsible for abduction, which is when the vocal folds are opening, and adduction, which is when the vocal folds are closing. You can remember adduction closed because you are adding the vocal folds together. There are two important theories or principles to talk about when you're trying to understand the physiology of sound production. The first of those is the myoelastic aerodynamic theory. Myo means muscle, elastic refers to the stretchable properties of the vocal folds, and then aerodynamic talks about the movement of air. Let's think about when someone closes their vocal folds or adducts the vocal fold, air in the lungs is now trapped and the pressure below the vocal folds is closed. Remember, the larynx sits on top of the trachea. The trachea leads to the lungs. So the vocal folds are closed, adducted. The pressure is building up beneath the glottis. The glottis is the space that's between the vocal folds. So anything below that is called subglottic. So that subglottal air pressure is building up to a point where it can overcome the resistance of those closed vocal folds. When that air pressure is greater than the force of resistance, the vocal folds are blown apart. And that's where the Bernoulli principle comes in. At this point, we start looking at the moving air as it rushes through the glottal space. According to the Bernoulli principle, as the speed of the moving air increases, the pressure that comes with this movement decreases. So the vocal folds were blown apart by the subglottic air pressure, and then the moving resulted in a decrease of air pressure. So then the vocal folds are muscular and elastic. They come back together and come back to their original resting position because of the Bernoulli principle and their elastic properties. Then the process begins again and again. As velocity increases, pressure decreases, and vice versa. Velocity is the rate of change of its position. So even though these two important principles help you to understand what's happening in speech production, more recent research has told us, as you see in your book on page 35, that there's another principle called the body cover model, and it talks about the vocal folds as multi-layered structures and how they move in more of a wave-like form. You can learn more about this when we talk about voice. Males are said to phonate at 125 times per second. Females phonate at 225 to 250 times per second, and children phonate 400 times per second. The length and thickness of the vocal folds affects phonation. So the thicker and shorter the vocal fold, the slower they're going to breathe. The thinner and longer they are, the faster they're going to vibrate. Think of a guitar string or a rubber band. The next system we'll discuss is the articulatory system. This system is divided into three cavities. The pharyngeal cavity, which is kind of that trumpet-shaped tube that ends behind the mouth and nose, or we call it kind of the back of the throat. The second cavity is the oral cavity, and it begins at the lips and ends at the back of the mouth. It also connects to the pharyngeal cavity. And then there's the nasal cavity that opens at the nose and ends at the back of the pharyngeal cavity. So sound that is generated at the larynx travels through these three cavities, resonates, and then hits the articulators to further shape the sound. Articulation can be divided into two different kinds of sounds: consonant sounds and vowel sounds. Consonant sounds are said to be voiced and voiceless, and vowel sounds are said to be only voiced. Voiced sounds are when your vocal folds are adducted or added together. Voiceless sounds are made when your vocal folds are abducted or open. Put your hand against your throat and feel the vibration when you make a voiced sound, such as ah, or b, or d, as in dog. Now put your hand against your throat while you make a voiceless sound, like certain consonants, such as p, as in p, or t, as in t. You should be able to feel the difference between a voiced and voiceless sound. One, you feel the vibration when the vocal folds are adducted, and the other, you feel nothing because there is no vibration because the vocal folds are. Articulation is thought of as being associated with movement. There are immovable structures in articulation, and there are movable structures in articulation. Your book talks mainly of the movable structures. If you will look at the picture that I have here and look at the picture on page 37 in your book, you can see the different structures used in articulation. Some of those structures include the lips, the teeth, the tongue, the hard palate, the soft palate, also known as the velum, also the alveolar ridge, which is the area behind your teeth, is used to make certain sounds. For example, you use your lips to make p, b, and m. You use your tongue and teeth to make the th sound or the t sound. We will talk more about where sounds are made in the section Speech Sound Disorders.